Question 4. In which equation does the oxidation state of the element that is underlined remains unchanged? So this is similar to question 3, in which it is essentially asking for a non-redox reaction as well. Okay, so if you take a look at question 4, are there any of the 4 reactions, the 4 non-redox reactions that is listed as an option here? Okay, there actually is. Okay, we take a look at option B. So sharper students that are able to identify what type of reaction option B is, okay, they will know that it is a non-redox reaction, because this is actually an equation for decomposition of carbonates. So calcium carbonate, when it's heated, it undergoes thermal decomposition to form calcium oxide and carbon dioxide, and in this process there is no change in oxidation state. All right, if you don't trust me, we can calculate the oxidation states of the elements in the equation now. Okay, so in calcium carbonate, we can, in this question, since the element is already underlined, right? The interested element is already underlined, we can just focus on this element. So in calcium carbonate, what is the oxidation state of carbon? Now, it is a carbonate ion, right? So I will write the formula of carbonate ion here. So let the oxidation state of carbon in carbonate ion be X. Okay, so X plus 3, and the oxidation state of oxygen in most compounds or ions is -2, correct? And what is the overall charge of this ion here? It's -2. So when you solve for X, -2 plus 6, the oxidation state of carbon in carbonate, it is +4. So look for a carbon containing product. It is present in carbon dioxide, right? So same thing, let the oxidation state of carbon in carbon dioxide be X. So X plus 2 oxygen atom, 2 times -2 equals to 0, because carbon dioxide is a compound. Compounds are neutral, so the overall charge is 0. When you solve for X, the oxidation state of carbon in carbon dioxide is also +4. Hence, the answer is B, if you calculate the oxidation state. Okay, but let's also calculate the oxidation state of the other underlined element in the rest of the options given. Okay, so for option A, magnesium element. All right, remember for the previous question, question 3, towards the end of the video, I've mentioned that generally, if the equation contains a free element, it is likely to be a redox reaction. So same thing for option A, magnesium is a free element. The oxidation state of free elements is 0. All right, and what is a magnesium containing product that we have? Magnesium oxide. So the oxidation state of magnesium in magnesium oxide, right? It is +2, because the formula of magnesium ion is Mg2+. So the oxidation state of magnesium in magnesium oxide is +2. So the oxidation state of magnesium has increased. All right, this means that magnesium has been oxidized. Okay, we move on to option C. All right, so A is not our answer because the oxidation state of magnesium has changed. We move on to option C, manganese in manganate ion, MnO4-. So students should be able to recognize that this is an ion in an oxidizing agent called potassium manganate. Okay, so let me write, this is an oxidizing agent. So look at what effect it has on iron 2 ion. Fe2+, the oxidation state, right, increases from +2 to +3 in Fe3+. So iron has been oxidized. Why? Because manganate is an oxidizing agent. Okay, so what happens to the oxidation state of manganese? It should decrease. Okay, so let's calculate the oxidation state of manganese in manganate. MnO4-. Let the oxidation state of manganese be X. So X plus 4. Oxidation state of oxygen in compounds. Most compound is -2. the charge of the ion is 1 minus equal to minus 1. So solve for x minus 1 plus 8 plus 7. So the oxidation state of manganese in manganate ion is plus 7. And in the product Mn2 plus, the oxidation state is plus 2. So MnO4 minus has been reduced as the oxidation state of Mn decreases from plus 7 in MnO4 minus to plus 2 in Mn2 plus. So it's also not our answer as there is a change in oxidation state. But again, students must recognize MnO4 minus is the anion, the negative ion in potassium manganate 7 or potassium permanganate, which is a popular or which is an oxidizing agent which students must memorize. Okay, last but not least, option D. Alright, in option D, we have zinc metal. Okay, free element, oxidation state 0, zinc sulfate. The charge of zinc ion is Zn2 plus, so its oxidation state is plus 2. Therefore, zinc has been oxidized. Okay, so it is a redox reaction. Right, so the answer for question 4, the equation where oxidation state of the underlined element remains unchanged would be B, as it is a non-redox reaction.